Hello, hi everyone. Welcome to the Student Brand. This is your Siva sir. Today we are going to discuss about electricity, electric current. Electric current will discuss. So actually, human colorful word we need to discuss. So already we completed in the evening session. Evening session we completed humanoid colorful word around 3 p.m. Okay. So that is the reason we are going to the electricity. So because we need to practice few problems and the concept too. So if you revise many times, it will be better. So before board exams, if you revise many times, so it will be helpful. At the same time, you will get effectiveness. Automatically you can prepare. So we can work out. You can practice in a better way. So I'm considering today. Today we are going to discuss about electric current. Electric current. Electric current, electric current, electric current, electric current. So, in this topic, we'll discuss more about charges. So, SI unit of charge and the rate of flow of charge is called current. Please teach simple. Okay, done. Sure, I will. In easy way, I'll teach. In easy way, only I'll teach. Yes. So normally you are considering when the electric current is passing through the conductor, electric current, electric current is passing through the conductor. Okay. So I hope we already know. So we are discussing grade 11 topics, mostly in a straight line at 6 p.m. So 6 p.m. class we are discussing. Now we'll discuss about electric current. Electric current. Electric current. Myopia, 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 myopia. Near distance we can see far distance we can see myopia, myopia, myopia. For that correction, we are using go for that correction, we are using concave lens, concave lens, concave lens. Myopia, 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 myopia. Hypermetropia, 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 hypermetropia. For a distance, we can see. Near distance, we can see. Hypermetropia, hypermetropia. For the correction, we are using convex lens, convex lens, convex lens, convex lens. New Cartesian sign convention, new Cartesian sign convention. All distance measured from the pole, distance are positive along the eccentric, distance are negative opposite to eccentric, distance are positive above the principal axis, distance are negative below the principal axis. New Cartesian sign convention, new Cartesian sign convention. All distance measured from the pole, distance are positive along the eccentric, distance are negative opposite to eccentric, distance are positive above the principal axis, distance are negative below the principal axis. New Cartesian sign convention, new Cartesian sign convention. All distance measured from the pole, distance are positive along the eccentric, distance are negative opposite to eccentric, distance are positive above the principal axis, distance are negative below the principal axis. Okay, come on everybody, let's get into the topic. So today we are going to discuss about electric current. Come on everybody, come on, electric current. So electric current is nothing but the rate of flow of charge. I equal to Q by T. So I equal to Q by T, the rate of flow of charge. Rate of flow of charge is called electric current. So rate of flow of charge is called electric current. I equal to, so I am considering electric current. Okay. So in this topic we'll discuss about I equal to Q by T. So normally we are considering I equal to Q by T. So what is I? Flow of charge. That is nothing but SI unit of current is ampere. SI unit of current is ampere. SI unit of current is Welcome. So SI unit of current is ampere. SI unit of current is ampere. SI unit of charge is coulomb. SI unit of charge is coulomb. SI unit of time is second. SI unit of time is second. SI unit of time is second. So electric current is defined as the flow of charge through unit cross section area. Flow of charge through unit cross section area is called electric current. Flow of charge through unit cross section area is called electric current. So I equal to Q by T. I equal to Q by T. SI unit of current is ampere. SI unit of charge is coulomb. SI unit of time is second. So 1 ampere equal to 1 coulomb per 1 second. 1 ampere equal to 1 coulomb per 1 second. 1 ampere equal to 1 coulomb per 1 second. 1 ampere equal to 1 coulomb per 1 second. 1 ampere equal to 1 coulomb per 1 second. 1 coulomb per 1 second. Come on. So SI unit of charge is coulomb. SI unit of current is ampere. SI unit of time is second. 1 ampere equal to 1 coulomb per 1 second. I equal to Q by T. I equal to Q by T. So then we can consider so here electrical circuit. So electric circuit. So I'm considering electric current. Next one, electric circuit. So what is electric circuit? Electric circuit is nothing but a continuous and closed path of an electric current. A continuous and closed path of an electric current is called electric circuit. A continuous and closed path of an electric current. A continuous and closed path of an electric current is known as an electric circuit. A continuous and closed path of an electric current is known as electric circuit. So normally we are considering electric circuit. Okay, so before doing this one, we will go to the appliances, electrical appliances. If I explain those points, so then remaining points easy to understand. So we'll work out on remaining points. So electric appliances. So electrical appliances, what are we are using? So we'll discuss now. So one, we are considering a cell. We are considering positive terminal, negative terminal, positive terminal, negative terminal. First one, next one. Battery, I'm taking the battery here. So battery I'm considering like this. So positive terminal, negative terminal, cell, battery. Okay. So second one, and next one, third one. So closed switch. Sorry, this is a open switch. And fourth one is closed switch. This is the closed switch. Okay. Fifth one, you are considering open switch and closed switch. And next one, we are going to the next one. Okay. So open switch or closed switch. Resistor. And sixth one, rheostat. Sixth one is rheostat. So I'm going to the rheostat. You can observe here. Rheostat, like this we can take the symbol, or we can take like this also. Rheostat, this is the rheostat. So the device which is, so without changing the voltage source, current can be altered. Okay, so current we can regulate by using a rheostat. So without changing the voltage source, we can adjust the current without changing the voltage source. We can alter the current. So that is nothing but rheostat. Next one, ammeter. Seventh one is ammeter. Positive terminal, negative terminal. Eighth one, voltmeter. Positive terminal, negative terminal. Next one, so bulb I am taking. So 10th one, bulb I am considering. Next one, so wire joining. So 11th one, wire crossing. wire crossing. So these are the points. Once again you can see cell, battery, open switch, close switch, resistor, rheostat, ammeter, voltmeter. So bulb, open. This one is wire joining and wire crossing. So now we can discuss electric circuit, a continuous and closed path of an electric current. So a continuous and closed path of an electric current is known as an electric circuit. An electric circuit. An electric circuit. Okay. So now we are going to the next one. Next one. So here you are considering. So I'm considering now. So this is the battery. Battery I'm taking. So from here ammeter. So and from here bulb I'm taking. Next switch I'm considering. Here is a closed switch. Current is passing from here to here. So I'm taking positive terminal, negative terminal. So current is passing now. So here you need to understand one thing. We understand one thing. When the current is flowing, so from positive terminal to negative terminal. So actually before finding the proton, neutron, electron, all those things. So here we are considering the conventional current. Conventional current. And the second one is electric current. Conventional current and electric current. So coming to the conventional current, so the flow of positive charges direction. The flow of positive charges direction is known as conventional current. The flow of electrons, so actually the movement of the electrons, because of the movement of electrons only, current will pass inside of the conductor. Because of the movement of the electrons only, current will pass in the conductor. So if you are taking normally positive charges we can consider. Positive charges we are considering. Okay, the flow of positive charges will be considered as a conventional current. So flow of electric current. So electric current will pass from negative terminal to positive terminal. Conventional current will move from positive terminal to negative terminal. Conventional current and electric current. So this is very, very important. So make sure that, and so we can also take conventional current will be taken as the direction of flow of positive charges. So electric current direction is taken as flow of negative charges. That is nothing but flow of electrons. So conventional current is positive charges. Electric current will be taken as negative charges. So that is nothing but conventional current and electric current. So normally if you are taking current, I equal to Q by T. So I am taking I equal to Q by T, the rate of flow of charge. Normally inside of the conductor, electrons will not move one. So like this, two, like this, it won't move. So there are many electrons will move like a bunch electrons are like that, it will move. So many number of, so that is the reason. So we can also take quantization of charge, plus or minus Ne. Quantization of charge we can take plus or minus Ne. I equal to plus or minus Ne by T. I am considering plus or minus Ne by T. So quantization of charge we are considering plus or minus, so Ne by T. So that is nothing but Q. So here you can consider in one electron how much charge is present, and one electron how much charge is present. So one electron, if you are taking 1.6 into 10 power minus 19 coulomb, on one electron how much charge is present? 1.6 into 10 power minus 19 coulomb. 1.6 into 10 power minus 19 coulomb. In 1 coulomb, how many electrons are present? 1.6 into 10 power minus 19. 1 by 1.6 into 10 power minus 19. Okay, so now you can consider now. So 1 by 1.6 into 10 power 19. 1 by 1.6 into 10 power 19. So now you are considering 1 by 1.6 into 10 by 10. If you do it, 10 by 10 if you do it, that is 10 power 19. So if you solve it, this one, if you solve it, you'll get in 1 coulomb, so 0.625 into 10 power 19. So if you're taking in 1 coulomb, so 6.25 into 10 power 18 electrons. So this is very important, very important. So normally you are saying in a conductor many electrons will flow, so we can't take only one. If only one electron is moving, one electron is passing, we can't say. So one electron is flowing, one electron is passing. We can't say current electricity is flowing. So there are many electrons. Number of electrons are flowing. That is the reason. Then only we can able to say current is flowing. Here you can see. Here I am considering. That is. Here I am considering. So when the electrons inside of the conductor, when the electrons are flowing, okay, so when electrons are flowing, so only one electron if it flows, one electron it flows, we can't say current is flowing. There are many electrons, there are bunch of electrons are flowing. So that's why it is integral multiple of, so Q equal to integral multiple of charge, Q equal to integral multiple of charge. Q equal to integral multiple of charge. So I equal to plus or minus Ne by T. So in one electron, how much charge is present? On one electron, 1.6 into 10 power minus 19 coulomb. On one electron, how much charge is present? 1.6 into 10 power minus 19 coulomb. So if you are taking 1 coulomb, in 1 coulomb, how many electrons are present? So in 1 electron, in 1 coulomb, how many electrons are present? In 1 coulomb, 6.25 into 10 power 18 electrons. In 1 coulomb, 6.25 into 10 power 18 electrons. So this is very important, very important concept. Very important concepts. Make sure that you are practicing this one. So very important, very important. So electric current, I equal to Q by T. SI unit of charge is coulomb, SI unit of current is ampere, SI unit of charge. SI unit of time is second, SI unit of current is ampere, SI unit of charge is coulomb, SI unit of time is second. I equal to electric current, electric current, I equal to Q by T. I equal to Q by T. I is SI unit of current is ampere, SI unit of charge is coulomb, SI unit of time is second. I equal to Q by T. I equal to Q by T. SI unit of current is ampere, SI unit of charge is coulomb, SI unit of time is second. So the rate of flow of charge is called electric current. Electric current. Now you are considering from this topic. So we can go to the next one. Come on. So come on. I equal to Q by T. I equal to Q by T. That is nothing but charge Q equal to plus or minus Ne. Q equal to plus or minus Q equal to plus or minus Ne. Q equal to plus or minus Ne. So N is the number of electrons. So in 1 coulomb, how many electrons are present? 6.25 into 10 power 18 electrons. In 1 coulomb, how many electrons are present? 6.25 into 10 power 18 electrons. On 1 electron, how much charge is present? On 1 electron. And so these 2 points are very important. On 1 electron, how much charge is present? 1.6 into 10 power minus 19 coulomb. 1.6 into 10 power minus 19 coulomb. In 1 coulomb, how many electrons are present? 6.25 into 10 power 18 electrons. Very, 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 very important. Make sure that you are practicing this one. So prepare carefully. Very, very important. Now you are going to the potential difference. Potential difference. Potential difference. Potential difference is nothing but potential difference is nothing but work done to bring potential difference. 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 In a conductor we are doing work. We are doing some work to bring one coulomb of charge, 1 coulomb of charge. So we are doing some work to bring positive charge from point A to point B. So we are doing some work to bring positive charge from one point to another point within the conductor. So within the conductor is called within the conductor is called potential difference. So V equal to W by Q. V equal to W by Q. So we are doing some work to bring unit positive charge from one point to another point. From one point to another point within the conductor. Within the conductor. If the work is done within the conductor, then we can say work is, so we can say that is nothing but potential difference. Potential difference is nothing but, so W by Q, V equal to W by Q. Work done to bring unit positive charge from one point to another point within the conductor is called potential difference. SI unit of potential difference is volt. SI unit of work is joule. SI unit of work is joule. SI unit of charge is coulomb. SI unit of charge is coulomb. SI unit of potential difference is volt. SI unit of potential difference is volt. SI unit of work is joule. SI unit of charge is coulomb. SI unit of charge is coulomb. SI unit of charge is coulomb. So work done to bring unit positive charge from one point to another point within the conductor. Work done to bring unit positive charge from one point to another point within the conductor is called potential difference. SI unit of potential difference is volt. SI unit of work is joule. SI unit of charge is coulomb. SI unit of charge is coulomb. So potential difference. This is the potential difference. Now we are going to the one more, electrical potential. Electrical potential. So what is electrical potential? Electrical potential is nothing but electrical potential. Work done to bring unit positive charge. So we are taking this field. So this is infinity. So we are taking the positive charge. We are doing some work. So same work done to bring unit positive charge from infinity to the required field. From infinity to the required field. From infinity to the required field. From infinity to the required field is called electrical potential. Electrical potential, that is nothing but V equal to W by Q. Same formula will be using. So potential difference is nothing but work done to bring unit positive charge. Work done to bring unit positive charge from one point to another point within the conductor. From one point to another point within the conductor is called potential difference. Electrical potential. Work done to bring unit positive charge from infinity to the required field. Work done to bring unit positive charge from infinity to the required field is called electrical potential. Electrical potential. So potential difference is completed. Electrical potential is completed. Next one we are going to the Ohm's law. Very, very important. Ohm's law. The potential difference across a metallic conductor. The potential difference across a metallic conductor is directly proportional to current flowing through it. The potential difference across a metallic conductor. So I am considering Ohm's law. So now you can see Ohm's law. Ohm's law I am taking. So in this case, statement. statement is, so we are doing some potential difference across a metallic conductor. So I am taking this resistor, switch, ammeter, so battery. Okay, ma. So I'll try to solve the questions related to electric current and see, simple only. Potential difference is nothing but within the conductor. Within the conductor, the charges are more. The positive charge is moving. So within the conductor, if you are taking within the conductor, so I'm taking the positive charge from one point to another point within the conductor. Within the conductor, if your work is done, that is called potential difference. Potential difference, PD. So if somewhere, so we don't know that point from infinity some point, so we can say some point in infinity from that point to required field where it is required. But this is within the conductor between one point and a point. So it may be so adjacent point, so it may be so different point within the conductor. But here, so the charges will be infinity. Suppose we don't know exactly where it is, but from there to required field, from there to required field. So we'll use battery like that. Battery we are considering. So we are so somewhere at electricity is there in the conductor. So from infinity to the so bulb is there. Bulb is somewhere is different place. So we are on the switch from here to there. It is current is flowing. So charges are moving. We don't know where it is, but required. So I want bulb should be on here. So there somewhere else we need to on. Then from there to here the current is flowing. So work done to bring unit positive charge from infinity to the required field is called electrical potential. Potential difference means within the conductor, within the conductor, within the conductor. Okay. So now you are considering, so current is passing through it. Current is passing through it. So positive terminal to negative terminal. So we are considering now here. So current is passing. So the potential difference across a resistor, the potential difference across a resistor is directly proportional to current flowing through it. The potential difference across the resistor, the potential difference across the resistor is directly proportional to current flowing through it at a constant temperature. At a constant temperature. The potential difference across the metallic conductor, across the given metallic conductor is directly proportional to current flowing through it. V is directly proportional to I. So V equal to IR. V equal to IR. So R is the resistance. It is the proportionality constant. R is a proportionality constant. V equal to IR. V equal to IR. So V equal to IR. So I equal to V by R. I equal to V by R considering. I equal to V by R. Okay. So here from this, I equal to V by R. R equal to V by I. So we'll do problems. Some problems we'll do it related to potential difference and electrical potential. So actually we thought to do problems. So once we'll recall the topic, then we'll go to the problems. I thought, so there are many problems. So we need to work out. This is a statement. Okay. Materials required. What are the materials required? Materials required. Materials required. First one is so 4 cells, 1.5 volts each, Second one, so first one is 4 cells 1.5 volts each. Next one nichrome wire, nichrome wire, nichrome wire, nichrome wire of so 0.5 meter length. So nichrome wire is an alloy of nickel, chromium, manganese and iron metals. Nichrome wire is an alloy of nickel, chromium, manganese and iron metals. And third one, so we can go for ammeter, ammeter, ammeter. Fourth one voltmeter, voltmeter, voltmeter. Fifth one switch, switch, switch and sixth one, so 4 cells nichrome wire, ammeter, voltmeter, switch, connecting wires, connecting wires, connecting wires. So these are the metals required. Once again, so what are the metals required for the doing activity of Ohm's law? So when, at a constant temperature, the potential difference is directly proportional to current flowing through it. At a constant temperature, so at a constant temperature, the potential difference is directly proportional to, at a constant temperature, the potential difference so at a constant temperature, the potential difference is directly proportional to current flowing through it. Even physical conditions also we can take. So V equal to IR, I equal to V by R equal to V by A. Materials required, 4 cells. 4 cells 1.5 volts each, 1.5 volts each, 1.5 volts each, 1.5 volts each. So 4 cells are there, 1.5 volts each, 1.5 volts each. And nichrome wire is an alloy of nickel, chromium, manganese and iron metals. Ammeter, voltmeter, switch and connecting wire. So these are the materials required. And coming to the procedure, so what is the process? Process is procedure. What is the process? First you have to connect one cell. So procedure we need to take procedure. Procedure first connect one cell and take the reading of ammeter and voltmeter. One cell, take the reading of ammeter and voltmeter. Connect 2 cells. Connect 2 cells and note down the reading of ammeter and voltmeter. 2 cells. And third one, repeat the process for 3 and 4. So repeat the process for 3 and 4. Repeat the process for 3 and 4. And mention the values in the tabular form. So mention the values. So 3 and 4 cells required. Next one we are going to the, so if you take one cell, connect one cell and note down the reading of ammeter and voltmeter. Connect 2 cells and note down the reading of ammeter and voltmeter. Connect 3 and 4 cells and mention in the tabular form. So I am considering 4 cells. So serial number of cells, ammeter reading is nothing but current. Ammeter reading is nothing but current. So we can go for current. Here current. I voltmeter reading is taking so voltmeter reading is potential difference. So V is directly proportional. V equal to IR, R equal to V by I, R equal to V by A. So take, I need to find out R value. R equal to V by A. R equal to V by A. For 1, 2, 3. So how many cells we are connecting? 4 cells. How many cells we are connecting? 4 cells. So connect 4 cells, and every time note down the reading of ammeter and voltmeter. That is nothing but current and potential difference, and mention current and potential difference, current and potential difference, current and potential difference, and to draw the graph for V and I. So draw the graph for V and I. So I on x axis, V on y axis, I on x axis, V on y axis. If you draw the graph, so that is for ohmic conductors, the substances which obey Ohm's law, those are called ohmic conductors. Ohmic conductors, the substances which obey Ohm's law, the substances which obey Ohm's law, those are called ohmic conductors. The substances which does not obey Ohm's law, so non-ohmic conductors. So here you can see the substances which obey Ohm's law, those are called ohmic conductors. The substances which does not obey Ohm's law, those are called non-ohmic conductors. Non-ohmic conductors. So here for ohmic conductors the graph is linear. For non-ohmic conductors, the graph is curved. So V on y-axis, I on x-axis. So this is very very important activity. Very very important activity. So please try to note down. So make a note of it. So very very important activity. So Ohm's law. Next one, factor depends on resistance. Factor depends on resistance. Factors depends on resistance. So we'll do problems. Problems are there. Problems are there. So related to current, related to Ohm's law, related to everything. So we'll discuss all the problems also. Okay. So now we are going to the one by one points, point by point. So now we will see. So now next one, factor depends on resistance. Factor depends on resistance. Factors depends on resistance. Factor depends on resistance. Resistance depends on length of the conductor. Resistance depends on length of the conductor. Resistance depends on area of the cross section. Resistance depends on length of the conductor. Resistance depends on area of the conductor. R is directly proportional to L by A. R is directly proportional to L by A. R equal to rho into L by A. R equal to rho into L by A. R equal to rho into L by A. So rho is the resistivity. So R equal to L by A. So here I am considering R is a resistance. R is the resistance. So you are considering R is the resistance. Rho is the resistivity. Rho is the resistivity. Resistivity. So I am considering here R is the resistance. Rho is the resistivity. So R is the resistance and rho is the resistivity. So here R is directly proportional to L, R is inversely proportional to area, R is directly proportional to L by A, R equal to rho into L by A. So here SI unit of resistivity they will ask for 2 marks. SI unit of resistivity now you are considering. So rho equal to RA by L. Rho equal to RA by L. Rho equal to RA by L. SI unit of resistivity is ohm. SI unit of area is meter square. SI unit of length is meter. So meter get cancelled. So SI unit of resistivity is ohm meter. So SI unit of resistivity is ohm meter. Very very important for 2 marks. Very very important for 2 marks. So make sure that you are noting down. Very very important for 2 marks. So R is directly proportional to N. R is inversely proportional to area. R is directly proportional to L by A. R equal to rho into L by A. R equal to rho into L by A. R is resistance. Rho is resistivity. Rho equal to RA by L. RA by L. So in exam this question they will ask for 2 marks. From here onwards you have to write. From here onwards you have to write. And 1 mark question also very important. So these factors they will ask. Factors for 1 mark. Factors, resistance depends on length. Resistance depends on area. So it is directly or inversely proportional. Resistance is directly proportional to length of the conductor. Resistance is inversely proportional to area of the conductor. Okay, so these 2 points are very very important. This is also called physical dimensions. This also called physical dimensions, length and area. physical dimensions. In exam they will ask, so resistance depends on physical dimensions or not? Yes, the resistance, especially individually, if they ask, resistance depends on length of the conductor, resistance depends on area of the conductor, and also resistance depends on physical dimensions. Coming to the resistivity, SI unit of resistivity is ohm meter. 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 Okay, so next one we are going to the difference between resistivity and resistance. Difference between resistance and resistivity. Difference between resistance and resistivity. Resistance and resistivity. Difference between resistance and resistivity. So this question they will ask for 3 marks. Resistance. So one side I am writing resistance, resistance, and another side I am going with the resistivity, resistivity, resistivity. So resistance I am taking, resistance I am taking. So resistance depends on length of the resistance formula R equal to rho into L by A. So here rho equal to RA by L, RA by L. So you can take the normal box. So you can draw the box. Okay, so I am breaking the box like this. So here first one, and coming to the second one, so resistance, SI unit of resistance is ohm. So ohm, if you are taking SI unit of resistance, SI unit of resistance is ohm. And symbols is separately they will ask here, SI unit of resistivity is ohm meter, ohm meter, ohm meter. So symbol, if you are taking symbol, so symbol third one is symbol, symbol, symbol of ohm, and here symbol resistivity, resistivity is ohm meter. And coming to the fourth one, resistance depends on length of the conductor and area of the cross section. Resistance depends on resistivity, does not depend on length and area, does not depend on length and area, length and area. Coming to the fifth one, resistance depends on temperature. Resistance depends on temperature. So resistivity depends on temperature, resistivity depends on temperature, resistivity depends on temperature. Next sixth one, so resistance depends on material of the conductor, resistance depends on material of the conductor. So here also sixth one, it also depends on material of the conductor, material of the conductor. So I hope it is very clear to you all. It is very clear to all. So it is very clear to you all. Okay. So this is about the answer. So resistance formula, resistance SI unit is ohm, resistance SI unit is ohm. Okay. So factor depends on resistance and resistivity. So resistance and resistivity. So SI unit of resistance is ohm. SI unit of resistivity is ohm meter. SI unit of resistivity is ohm meter. Okay. So these are the points, very important points. So make sure that you are working on it. Make sure that you are working on it. Make sure that you are working on it. So these points are very important, very important. So 3 marks question they will ask for, they will ask in exam for 3 marks. This question they will ask 3 marks question. Next one we are going to the next one. Resistors are connected in series combination, resistors are connected in parallel combination. Resistors are connected in series combination and resistors are connected in parallel combination. Now we will check now. Resistors are connected in series combination, resistors are connected in parallel combination. Resistors are connected, resistors are connected in series combination, so here you can see Here you can see. So I'm taking three resistors. I'm connecting three resistors. So resistor 1, resistor 2, and a resistor 3. So that is connected in series combination. So battery, I'm taking the battery. So switch. So closed switch, current is passing. So here positive terminal, negative terminal. So here across R1 we are connecting V1. Across R2 we are connecting V2. Across R3 we are connecting V3. So R1, R2 and R3. R1, R2, current is flowing. So current is same throughout the circuit. Current is same throughout the circuit from Ohm's law. From Ohm's law, V equal to IR. V equal to IR. So from this, so Vs equal to IRS. Vs equal to IRS. The potential difference. So from the battery, whatever it is going, the potential difference. So Tavnesh, hi. So everybody, hi everyone. So welcome to the class. So IRS equal to IR1 plus IR2 plus IR3. So we can take I common. RS equal to I, we are taking common R1 plus R2 plus R3. So now we will get IA get cancelled. RS equal to R1 plus R2 plus R3. If n number of resistors are connected in series combination, so RS equal to NR. RS equal to NR. N number of resistors are connected in series combination. Then we can take RS equal to NR. RS equal to NR. So now resistors are connected in parallel combination. 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 Parallel combination. Parallel combination. Parallel combination. Resistors are connected in parallel combination. Parallel combination. So here you can consider, so I am taking one resistor, one more resistor, and third resistor. So those three resistors are connected in such a way, so potential difference across the resistor is same. Potential difference across the resistors is same, current is flowing. So positive terminal, negative terminal. So across this one V1 I am connecting. So here I am taking V. So this is the R1, R2, R3. So current is flowing. So that is dividing into I1, I2, I3, I1, I2, I3. Current is flowing like this. So current is flowing. Okay. So current is flowing from Ohm's law, from Ohm's law, from Ohm's law, from Ohm's law, from Ohm's law. V equal to IR. V equal to IR. I equal to V by R. I equal to V by R. Because current is dividing I1, I2, I3. Current is dividing into three parts. So total current in parallel combination. Total current is in parallel combination. Total current in parallel combination. Total current in parallel combination IP equal to I1 plus I2 plus I3. So IP equal to I1 plus I2 plus I3. So V by R equal to V by R1 plus V by R2 plus V by R3. So I am taking V common. If you are taking V common, 1 by RP equal to 1 by R1 plus 1 by R2 plus 1 by R3. So we are taking anyway common here. We am writing we get cancelled. The formula is 1 by P equal to 1 by R1 plus 1 by R2 plus 1 by R3. So 1 by R3. This is the formula. So 1 by RP equal to 1 by R1 plus 1 by R2 plus 1 by R3. So this is the resistors are connected in parallel combination. Once again, so R1, R2, R3 are connected in parallel combination. Current is flowing through it. So V equal to IR, I equal to V by I. So the current is passing from the battery, that is equal to I1 plus I2 plus I3. IP equal to I1 plus I2 plus I3. V by RP equal to V by R1 plus V by R2 plus V by R3. So V into 1 by RP equal to 1 by R1 plus 1 by R2 plus 1 by R3. VV get cancelled, 1 by RP equal to 1 by R1 plus 1 by R2 plus 1 by R3. So if you are taking the same, if n number of resistors are connected in parallel combination, 1 by RP equal to n by R. RP equal to R by n. So this is very important formula. So related to this one more question they will ask in the exam. Related to this one they will ask, and related to current is different. And Vp equal to V1 equal to V2 equal to V3 equal to V. So everything we were taking V only. That's why we are cancelling V. So potential difference is common, so we are cancelling potential difference. So this formula is very important, very important. And resistors are connected in parallel combination. 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. So this is very important. Keep in mind, this is very important. Make sure that you are practicing this one. Make sure that you are practicing this one. Okay, so these all are connected in parallel combination. If they connected in parallel combination, we'll get like this. Okay, so next one we are going to the next one. Next one is the heating effect of electric current. 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 So heating effect of electric current is nothing but when we are giving the current to the conductor, so that conductor will utilize whatever amount we are giving, the total amount will be converted, will be dissipated, will be converted, will be dissipated entirely in the form of heat, entirely in the form of heat. So I am considering here V is V equal to W by Q, V equal to W by Q, W equal to V into Q. So V equal to W by Q. So this is the formula of potential difference. Potential difference is nothing but work done to bring unit positive charge. Work done to bring unit positive charge from one point to another point. Work done to bring unit positive charge from one point to another point within the conductor is called potential difference. V equal to W by Q, W equal to VQ. So we know rate of doing work is called power. Rate of doing work is called power. P equal to W by T. So P, rate of doing work is called power. So W equal to VQ by T. So P equal to, so V into Q by T. So what is V? V into Q by T. So we know V by T, Q by T is current. 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 So then we can say V into I. So energy given to the conductor is nothing but power into time. So P equal to VI. So whatever the energy is given to the conductor, whatever the energy is given to the conductor, that conductor, so that will become into heat. So Vi into T. So we know V equal to IR. We know V equal to IR. So the value H equal to IR into I into T. So H equal to I square RT. H equal to I square RT. This is also known as Joule's law of heating. This is also known as Joule's law of heating. This is also known as Joule's law of heating. Joule's law of heating. Heating effect of electric current is also known as Joule's law of heating. H is directly proportional to square of current. H is directly proportional to resistance. H is directly proportional to time. H is directly proportional to time. So this is about so heating effect of electric current. Applications of heating effect of electric current. Applications of heating effect of electric current. Okay. So applications if you see, okay, applications of heating effect of electric current. Applications of heating effect of electric current. So electrical cooker, electrical oven, electrical cooker, electrical oven. So heater, like iron box. These all examples for heating effect of electric current. 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 Okay, Samir, if it is required, definitely I will so contact you. Thank you so much for our there is any requirement. So thank you so much for asking. Now you are going to the next one. Short circuit. Short circuit is nothing but direct contact of live wire and neutral wire takes place. That is called short circuit. And overloading is nothing but so high voltage appliances on at a time. Heavy amount of current will be drawn from the mains. So high voltage appliances on at a time, heavy amount of current will be drawn from the mains. Then so it leads to the short circuit. That is about overloading. Next one we are going to the live wire. So next one we are going to the fuse. Fuse is a device which is safeguard the appliances when heavy amount of current comes more than it is required limit. Then it will it melt and breaks the circuit. That is a safety measures we are using in household. That is fuse. Second one is earthing. So fuse is a device which is used for safeguard the appliances, protecting the appliances. When heavy amount of current is flowing in the circuit more than it is required limit, so then it melt and breaks the circuit. Coming to the earthing also a heavy amount of current will be there, or extra current is there in the circuit, so that will send to the ground. That is earthing. These are the two safety measures. These are the two safety measures we are using in household. Coming to the live wire, if you are taking live wire, is potential difference is 220. First one. Second one is neutral wire is potential difference is 0, and the earth wire is taking green wire. So live wire is red insulation. Black negative terminal is black color, and coming to the earth wire is green color. Insulation. The potential of earth wire is 0 volt. So here we are considering here Amanchi, hi. Here the potential difference of live wire is 220 volts. The potential difference of neutral wire is 0. The potential difference of earth wire is 0. Once again, the potential of live wire is 220. Potential of neutral wire is 0. Potential of earth wire is 0. The potential difference between live wire and neutral wire is 220. The potential difference live wire and earth wire is 220. Okay. So these are the points. Next one we are going to the problem discussion. We'll do problems one by one. I'll write the question, try to answer the question. Okay, so we'll do some problems. Till now we are explaining the full concept, so I hope concept completed. So entire concept. If you have any doubts in it, you can ask me. So otherwise we'll go to the problems. So I'm going to the problems. Okay, so here we can see problems, electrical problems. We need to do it. Electricity problems. So every time we are going this point, so we'll go to the different points. Resistance of the material. So we'll work out on resistivity of the material. This also okay. Okay. Heating effect of electric current. So these questions are there. We'll do it. Compute the heat generated. So question. Compute. So means. So related to question we are doing. So those are doing. So you can try once. Those who know this question, you can try once. This question. Compute the heat generated The heat generated while transforming while transferring 96,000 coulomb of charge of charge in 1 hour in 1 hour through a potential difference through a potential difference potential difference through a potential difference of 50 volts. So try this question. So we'll discuss this question. So those who know the answer, you can tell me. So meanwhile, you can work out on this question. Once I try, everyone. Try this question. Once I try this question. So okay, anybody got the answer? Can you tell me? Those who got the answer, let me know. Otherwise, we'll do it. Here. Okay, so here we can observe. So we can observe one thing. So they given, observe carefully. Compute the generate the while charging. So this is the charge. So in 1 hour, time is 1 hour. So potential difference is given. So we know H equal to I square RT, right? I square RT. So we know V equal to IR. V equal to IR. So H equal to, so IR into I into T. So H equal to IR is nothing but V. So we know I equal to Q by T. Q equal to I into T. In the place of Q, so we can take HQ. So H equal to V equal to how much? Potential difference 50. So charge is how much? So multiply. How much you'll get? That is 4.8 into 10 power 6 joule. This is the formula. So okay. So we'll go to the next problem. Next problem. Next problem directly you can do it with the based on the formula they given. Next problem. Next problem related to complete formula itself. I'll explain. So direct formula we can use. Next problem. Directly we can use formula to do the problem. So if you know the problem H equal to I square RT, so you can use that formula. But how they will ask in the format of questions, so we'll do those problems. We can see question. An electric an electric iron an electric iron of resistance of resistance of resistance 20 ohm takes a current of takes a current of 5 ampere. Calculate the heat developed in 30 seconds. Heat developed in 30 seconds. So find out the question. The heat developed in 30 seconds. In 30 seconds. Okay, try to do it. Question mark. So underline the question, what exactly given. Try to solve it. Okay, so now you can see, I'll underline so you can observe. So here an electric iron of resistance. An electric iron of resistance is given. Resistance is given. R equal to how much? 20 ohm. And a current how much given? I. Current 5 ampere. And calculate the heat generated in 30 seconds. So T equal to 30 seconds. 30 seconds. Now what is the formula? H equal to I square RT. H equal to I square RT. So you can use this formula. H equal to I square RT. H equal to I square RT. We can use this formula. So you can use and substitute the formula and calculate how much you'll get. So H equal to I means 5 whole square. R means 20 and I means 30. Okay. Now try to solve it. 25 into 20 into 30. How much? So H equal to 15 kilojoule. So this is the answer. So try to solve it. Try to check it. So underline every time when you're reading the question, you have to underline. So what exactly they given? So R, I and T. Okay. So one more question. One more question. An electric motor. Next question. An electric motor. An electric motor. Question. An electric motor takes electric motor takes 5 ampere from a 220 volts line. Full stop. Determine the power of the motor power of the motor power of the motor motor and the energy consumed in 2 hours. Can you do it? This question. Try to solve it. I'll start explain at 10:30. 10:30 I'll start. Explanation at 10:30. Explanation at the rate of 10:30 p.m. Okay, so here you can see, here you can observe in this question, so an electric motor takes, so current is given, potential difference is given, determine the motor and the energy, so in 2 hours, time is given. So normally we know, write the given data first, given data. So if you write the given data, I equal to 5 ampere and V equal to 220 volts, time equal to 2 hours. Okay, if the given time, so what we have to do it? So we must identify in seconds. 2 into 60 into 60. So how much? 72? 7200 seconds. Now, so what we have to find out? Power equal to VI. That is nothing but 220 into 5. So how much? 220 into 5. So 1100 watt. Next, energy. Energy equal to P into T. Energy equal to P into T. So P equal to how much? Time equal to how much? So total how much? 7.92 into 10 power 6. 7.92 into 10 power 6 joule. Joule, that is energy. So note down, we'll go to the next question. Now I'll go to the next question. An electric bulb. So very important. So note down. Question: an electric bulb is rated 220 volts. So 220 volts. An electric bulb is rated an electric bulb rated 220 volts 220 volts and 100 volts when it is operated on 110 volts. The power consumed will be options I'm giving. Option A 100 volt, option B 75 watt, option C 50 watt, option D 25 watt. So which one is the answer? Can you tell me? Find out. Just check once. Explanation will be given at 10:40. Explanation at the rate of 10:40. Shreya, hello. Halchal. Hi Shreya. So we are doing problems. So try to join. Okay, so in this here you can observe one thing. In this problem here, in this problem so electrical bulb is rated. So rated they given means, so here power is given 100 watt and the voltage is given 220 volts. From this we can find out R value and power is consumed. Okay, so power operated here 110 volts. and R is same, we can find out power, right? So that is a concept, that is a method to solve. Huh? So now we can see. So now resistance we have to find out. P equal to VI. So from this V square by R we can take. From this R equal to V square by R, V square by P. So R equal to V how much? First case 1 and case 2. Case 1 220 whole square by 100. So if you solve this one, you will get 484. Then second case we have to find out power V square by R. Power equal to V square by R. So V equal to how much? 110. 110 whole square. Power is same, 484. Then solve, how much you'll get it? How much you'll get it? Tell me. So which one is the option? Can once again, power given, potential difference is given, we can find out R value. So R is same because electrical bulb is still operated at 220 and 180. Okay, operated at 220 and 180, right? Sorry, 220 and 110. 220 and 110. So resistance is same. Find out the resistance. So use here. So resistance is there, voltage is there. Then we can find out the power. So that only we are doing. How much you'll get it? So we will get 25. I hope 25 watt. Check once whether you are getting correct value or not. This is the answer. Is it clear? Okay, we'll go to the next one. Next problem. So this question will do. Okay, shall we start? So question number calculate the amount of charge the amount of charge that would flow in 1 hour through the element of an electric current, the element of an electric bulb, drawing a current of 0.2 ampere. Can you find out the question? So what is the answer? Can you solve it? Can you solve this question? So explanation will be given at the rate of at the rate of 10, 50. Answer is 720 is correct. So user ID by your answer is correct by. Very good. Correct answer. Claps. No claps. Only drums. Okay. Okay, chalo, explanation time. Ready for explanation? Correct only. That is the answer. So here you can see. I given, current is given. So current is I. And hour, 1 hour is given. Okay, so that's enough. Now I equal to 0.2 ampere. Current time equal to 1 hour. 1 hour equal to 60 into 60. 60 minutes and 60 seconds. We'll get 3600. 60 into 60. 60 into 60, you'll get 3600 seconds. Now, we'll go to I equal to Q by T. Q by T, so they're asking, calculate the amount of charge. Charge they're asking Q. So from this, Q equal to I into T. I equal to how much? 0.2. So T equal to how much? 3600. So answer is 720 coulomb charge. Ma, this is very important question. Okay, we'll solve. So for grade 12 also we'll do it. Now it is 10, grade 10 it's going on. Grade 11 already it is going at 6 p.m. for grade 11 students. You can join at the grade 11 now. So 6 p.m. you can join, boy. So that time I'm every day 6 p.m. for grade 11 students topics I'm teaching. So it will be helpful for to you. Okay, you can join at the time. 12th I will start soon. So this for grade 10. So that's why I'm explaining. Grade 12 also I'll start. Okay, so timings only it's not adjusting. Because that reason I'm waiting. I'll start grade 12 also. So now you can see. Do you teach IIT level topics also? Yeah, that only boy I'm telling. Thank you for your concern. So instead of doing that one, one thing you do, subscribe. First point, subscribe and watch the videos. NEET level videos are there. JE level topics are there. You can watch the topics. Light reflection, diffraction. Third one, spread one word regarding the student band to your friends or your so juniors or seniors. So that is more than enough for me. Subscribe and NEET level problems are there. So you can check. And one word regarding the channel. You can spread one word to your friends. So ask them to join to the channel and listen to the class and ask the doubts. Thank you so much for your concern. Like done. Like number 18. Thank you so much. Next one. We are going to the very important question. A household a household uses very important question. So this question will come for 4 marks or 5 marks. Following electrical appliances so first one, refrigerator, refrigerator of rating, rating 400 volts, 400 volts for 2 hours each day, for 2 hours each day. Second one, so two electric fans, two electric fans of rating 80 watts, 80 watts each, 80 watts each for 12 hours, for 12 hours, 12 hours, 12 hours each day. Third one, 6 electrical tubes of rating, 6 electric tubes, 6 electrical tubes of rating 18 watts each for 6 hours, each day. Calculate the electricity bill of the household for month of June. The electricity bill of the household for the month of June, if the cost per unit of electrical energy, electric energy is 3 rupees. 3 rupees. RS 3 rupees. Full stop. Can you do this question? Try to do this question. If you have any doubts, you can ask. Explanation will be, because this is a lengthy problem, so explanation I will give. Explanation at the rate of 11:05 p.m. Okay, so here you can see in this problem, so they given, so we need to find out the electricity bill. For finding the electricity bill, we need to do one thing. So that is, so every time you are doing this one, so you must identify, first point is, so here refrigerator of rating 400 watts for 2 hours. For 2 hours. So means, so E1 equal to 400. Refrigerator is only one, 2 hours is, so we'll get 800 watt hour. This is 800 watt hour. We must convert into kilowatt hour. So by 1000 you have to take. So 800 by 1000 if you are considering, how much you will get? 0.8 kilowatt hour. So first one. Second one, so two electrical fans of rating. So 80 watt, each for 12 hours. 12 hours. So we have to take number. So E2 equal to N into PT. So if number is there, so that number you have to take. Number of electrical bulbs or electrical fans are like that. Okay, two electrical fans they given. So second one is two electric. So first one is completed. Second one is two electrical fans. 2 into two electrical fans they given. 2 into, so you can consider 2 into, so 80 watts given. 80 watts into time how much given? 12 hours. Time how much? 12 hours. So if you solve it, how much you'll get? If you multiply, so 2 into 80 into 12, you'll get 192. 192 by 1000, so you'll get so much? 1.92 kilowatt. 1.92 kilowatt hour. Okay, so third one E3. E3 is, E3 if you see, E3 how much? 6 electrical tubes. 6 electrical tubes. 6 into, so 18 volts. 18 volts. 18 volts into 6 hours. 6 hours. How much you'll get? I hope you'll get 648. 648. 648. So by 1000 you have to take. So here how much you'll get? So multiply 80 into 12 into 2. I have 1.92. Just check once. Here also 642. Then we'll get 0.648. And if you have to add everything, we have to add everything. If you add, how much you'll get? 0.8 plus 1.92 plus 0.648. Okay, for June month they mentioned. So you have to multiply with 30. So if you multiply with 30, how much you'll get? So 101.04. Total month energy consumed 101.04. Okay. Then if you again they mention for each unit is 3 rupees. Again if you multiply with 3, how much you'll get? 303.12 rupees. So check once if any changes are, let me know. Do you have any doubt? Okay. So that's enough for today class. Thank you so much for joining. So we'll see remaining questions in next class. So until then, So this is Vasava sir signing off. Thank you so much.